All right, guys, welcome to lesson 11.5. Today we're going to see that trigonometric equations have infinitely many solutions, and because of that, we're going to learn how to find something known as the general solution. And what a general solution is, basically, it's a little formula that helps you represent all the possible answers, which is really an infinite number. And then we'll learn how to use that general solution to create a desired set of particular solutions. All right, so to begin this process, let's do a little exploration. Now, you guys don't have to write this slide down, just observe for a minute. So let's say I have sine of 30, okay? Now, I'm going to add 360 degrees to that. So if I add 360 degrees to that, I'm going to get 390. And I'm going to add 360 again, and I'm just going to keep doing it. So the next one will be 750. The one after that will be 1,110. You know, we could even go backwards, and instead of adding 360 and over again, what we could do is we could subtract 360 from 30. So we'll do that one too, just to kind of add a little extra flavor there. Now, punch all of those into your calculator and see what you get. I would encourage you to pause the video here and do that, and then when you unpause it, we'll discuss your results. So what you should have noticed is that all of them had the same answer. They were all 0.5, okay? And really, I could have just kept doing that forever. I could have just kept adding 360 or subtracting 360. So long as that starts with that basic number 30 there, we're going to get the same thing every time. And so therefore, we could see that a trigonometric equation like this one, sine of theta equals 0.5, that theta really has an infinite number of possibilities. Okay, so far, in this class, when we've been solving equations like this one, we've really just been finding two. And those two answers have been the answers that are on our unit circle. But really, there's an infinite number of them. And we're going to learn about how to find a certain number of those today. So let's go ahead and begin here. Let's go ahead and talk about these four functions: sine, cosine, secant, and cosecant, and something called periodicity and general solutions. So first of all, let's kind of bring this back to what we were talking about a second ago. Let's say a sine of theta equals 0.5. Now, the one that we knew right away was this guy is 30. Okay, that's 30 degrees. But we also know there's one over here, and that would be 150 degrees. So there's technically two solutions to that on our regular unit circle. But we also know that if I take like the 30, for instance, and I add 360 to it, I land right back where I started. The same thing applies to the 150. If I were to add 360 to that, I land right back to where I started. So anytime you add 360 or subtract 360, which would be going in the opposite direction, you land right back where you were. And as you guys may remember, those are what we call coterminal angles. Now, functions that repeat every so often are said to be periodic functions. Okay, so trig functions are periodic. So periodicity, the number of degrees it takes for a trig function to reach a coterminal angle. So for sine, cosine, secant, and cosecant, the period of those functions is 360 degrees. You have to go all the way around before you land back at the same spot. Okay, and so the period of those functions is 360 degrees, or if you want to say it in radians, it's 2 pi radians. 2 pi is a full circle in radians. All right. So you notice that we started off with 30 degrees, and then we added 360 to it. And then we added 360 again, and again, and again. So another way we could write this in a shorter way is, like if I had three 360s, you could write 3 times 360. Or you could write 4 times 360. Or if you wanted to subtract 360s, Oops, I'm writing that wrong. These are supposed to be 30s there. Sorry about that. Or you could subtract any number of 360s. But either way, all of these are going to give you coterminal angles that will give you the same sine value, okay? And so what we're going to share with you now is we're going to share with you the general solution. The general solution for these four functions is you take the angle that you would normally get by solving, and you're going to add 360n to it, where n represents just some integer like 1, 2, 3, 4, 5, 6. So you're adding 360 a certain number of times. And n can also be negative. In that case, you'd be subtracting 360. Now you'll notice that I put two angles here, and that's because, as you guys know, if I had something like sine of theta equals 0.5, there's two answers on our unit circle, and they're completely different ones. You have 30 degrees, and then you have 150 degrees. And so both of those can be written as a general solution. So the first one would be 30 degrees plus 360 any number of times. So we put n there. Or we could have 150 plus 360 any number of times. Now, if we're working with radians, instead of adding 360n, you would add 2 pi n, okay? But the idea is the same. Now, you'll notice that I didn't include tangent and cotangent on the last slide, and that's because tangent and cotangent are kind of funny. Let's say I said tangent of theta is equal to 1, okay? Well, tangent of theta is equal to 1 in two places. Right up here in the middle, and that's at an angle of 45 degrees. And it's also equal to 1 over here, which is at an angle of 225 degrees. Now, tangent is interesting because it has a period not of 360, but of 180 degrees. And you can kind of see that here. From our first line to our second one makes a half of a circle. So from this answer to the next answer is 180 degrees. In other words, if you were to add 180 to 45, you would get the next one. And if you wanted to add 180 again, then you get another place over here at 45, but that still gives you the same tangent value. Or you can add 180 again, or 180 again. So basically, tangent repeats its values every 180 degrees. Okay, so the period of tangent and cotangent is 180 degrees, or you could say pi if you're doing radians. So the general solution for tangent and cotangent will look kind of like the last one. It's just that instead of plus 360, it's plus 180. Okay, and you'll also notice that there's only one angle. And the reason for that is because when you're doing sine and cosine and tangent and cosecant, you have two angles. You have one here and you have one here, and those are always going to be different. You can't really get from this one to this one necessarily by doing a particular mathematical operation the same every time. These two angles are completely different. Whereas when you're doing tangent, the two options that we usually find, they're always 180 degrees apart. So you really only need one equation to find all the possibilities. If you know that this angle is 45, for instance, if you add 180 to that, that just gets you to the next angle, which is over here, and it has the same tangent value. And then if you add 180 again, it gets you back here, right? So you can add 180 as many times as you want, and it's just going to keep giving you the next answer. Okay, so tangent and cotangent have a different period. They repeat every 180 degrees, whereas the other four repeat every 360 degrees. Tangent and cotangent also only have one equation for their general solution, whereas the other four have two equations for their general solutions. So, what is a general solution then? It's a formula that can generate an infinite number of answers for any periodic function. How do we write a general solution? First of all, just solve the equation like we have been, okay? We've done it in two ways, one with a calculator and one with a unit circle. So whatever method we're going with, just solve it like we have been. And then after that, if it's sine, cosine, secant, or cosecant, we're just going to put plus 360n at the end. Or you could do 2 pi n if you're doing radians. And if it's tangent or cotangent, we'll add 180n at the end. Okay? And just remember that for these guys here, tangent, cotangent, we only need one equation, whereas for these four, we have to do both solutions with a separate general solution. All right, so we will go ahead and jump into some examples here. All right, so step one to find the general solution is just to solve it like we normally would. Since this is a and we're going to use the unit circle, by the way, for the first few problems here today. So we're going to look at our tangent unit circle. And if you guys look at that, you don't need to draw this because you already have a tangent unit circle. But tangent is equal to -1 here and also here. Okay, and those two angles are, for that one, 135 degrees. And we really don't care about the other one because I already know it's just going to be 180 degrees away. So my solution is 135 degrees, but since we're doing tangent, I'm going to add 180 in. And that's what we call the general solution. Okay? The reason it's a general solution is because now I know that if I start with 135, I can find as many other answers as I want to, so long as I just add or subtract 180 any number of times. Okay? So let's go ahead and take a look at another example. Number 2. Let's look for the places where sine of theta equals -1. Matter of fact, I think I'm going to change that one just a second. I changed it because that one would have only had one solution, but I wanted you guys to see one that has two solutions. So here we go. So once again, solve it like normal. So sine is the y value. So we're going to look at our normal unit circle here. We're going to ask ourselves, where does sine have a y, or where does our unit circle have a y value of radical 3/2? And there's two spots where that happens, here and here. So for the first angle, that would be at 60 degrees. And then for the second angle, that is at 120 degrees. All right, so we have two solutions there, and they're completely different. It's not like you can get from one to the other by adding 180 or something like that. It'll always be different. So there's the specific solutions that are on our unit circle. Now, since we're dealing with sine, the period of sine is 360. So I can get 60 to repeat itself if I add 360 to it any number of times. I can also get 120 to repeat itself if I add 360 to it any number of times. And so there are the two general solutions for sine. So remember, for tangent, you only need one. For sine and cosine, you need two. All right, let's go ahead and take a look at one more example. So for this one, we're going to be doing it in radians. So let's begin. Now for secant, you may recall that anytime you have secant or cosecant or cotangent, we have to start by doing the reciprocal before we solve it. So the reciprocal of secant is cosine, and the reciprocal of -2 is a -1/2. And so I'm looking on my unit circle for where the x values are -1/2. And that happens in two places. One of them is up here, and the other one is down here. Now, the first angle here, we would usually say is 120, but remember, we want radians. And so that angle in radians is 2 pi over 3. And then the other angle here that goes around to here, that one is, what is that? That's 4 pi over 3 in radians. Okay, so I have my two solutions, 2 pi over 3 and 4 pi over 3. But we want the general solution, and since this is cosine or secant, then the period is 360. So we're adding, not 360 though, right? We're doing radians, so instead of 360, we do 2 pi n. So for radians, instead of 360 n, we put 2 pi n. So there you guys have it. All right, so just to do a quick recap about the differences between these four, is that, first of all, you get a period of 360, so you're adding 360 in, or 2 pi. And also you get 2 solutions for these ones. Okay. When it comes to tangent or cotangent, however, the period is only 180, so we only add 180 in, or pi in, and we only get 1 general solution. So keep that in mind, and do pay close attention to whether or not we're doing radians or degrees. So here's your guys's. This is some student practice. Pause the video and give these a try, but do bear in mind that this last one here is supposed to be in radians, and the 4 and 5 are in degrees. All right, so pause the video here. When you unpause it, I will have the solutions available for you. All right, so here are the solutions. Now for number 4, interestingly enough, there's going to only, even though it's cosine, you're only going to have 1 solution on that one, and that's because cosine equals 1 at only 1 place, and that is at 0. And so if you put 0 plus 360 in, you just get 360 in. For number 5, it's cotangent, so you'd have to start by taking the reciprocal and solving, and then you get 45. And since it's cotangent, we add 180 in, and you only have 1 general solution for cotangent. And then finally for cosecant, take the reciprocal and solve for theta, and you'll get 7 pi over 6 and 11 pi over 6. And since cosecant has a period of 2 pi in radians, then we're adding 2 pi into those 2 general solutions. So these are general solutions, and like I said, these are formulas that can generate for us any number of answers we want. So for instance, this is my general solution for this one over here. But if I plug in a number for n, like let's say I plug in 2, well, 2 times 180 is 360. And 360 plus 45 would be 405. Well, that is another solution to this. That's an answer to that equation. If you did cotangent of 405 degrees, you would get 1, just like if you did cotangent of 45. So this is a formula that can generate for us any number of solutions that we want. And whenever we try to find some specific solutions, those are what we call particular solutions. And that's what we're going to look at next. So up until now, every time we've solved a trigonometric equation, I've always told you to go from look for answers where theta is between 0 and 360. In other words, just stay on the normal unit circle range. But since there's an infinite number of solutions, we can go beyond that now by taking our general solution and plugging in multiples of n until we've found all the possibilities for the range that they want. So in other words, instead of saying, find me all the answers between 0 and 360, I might say, find all the solutions between 720 degrees and positive 720 degrees. So once you have your general solution, you can just keep plugging numbers in for the n and keep finding more answers until you've gotten to anything that's between these two but not beyond them. Okay, so let's go ahead and generate some particular solutions now. All right, so this is example 2. Something to take note of is this. I don't want just answers between 0 and 360 now. I want answers between negative 360 and positive 360. So let's begin. The first step is to find the general solution. And to do that, we're just going to solve it like we normally would, which is I'm going to add 5 on both sides. And that leaves me with 0 equals sine theta. And then looking at my unit circle, sine is equal to 0 in 2 places. One of them is here, and one of them is here. And so my 2 answers for theta are 0 and 180 degrees. Okay? Now, since we're dealing with sine, we're going to put plus 360 in on both of these. And there's my general solution. Okay? So let's go ahead and start finding as many answers as we can here. All right, so for this, I'm just going to make a little table, and you don't have to make a table necessarily, but this is how I'm going to do it. So we have our first general solution, 0 plus 360 in, and then we have our other general solution, 180 plus 360 in, okay? And so let's go ahead and start with n equals 0. I'm going to put that in the middle of the table here. If I plug in 0 for n, what would that give me? If I plug 0 in for n here, what's 360 times 0? Well, that would be 0. And what's 0 plus 0? That would be 0. So 0 is one of my solutions. Let's plug in 0 here as well. If I plug in 0, what would I get to that one? I would get 180, right? Let's go ahead and plug in n equals 1 now. So now I'm going to plug in 1 for this 360 times n. So what's 360 times 1? Well, that's 360. What's 360 plus 0? Well, that would be 360. What if I plugged in 1 here? Well, that would be 360. And what's 360 plus 180? Let me see. That'd be 0, 4, carry the 1, 540 degrees. Okay. Now, I'm going to stop going in that direction. We can also go backwards. I can plug in n equals -1. So if I plug in -1, what do I get? 360 times -1 is -360. Plus 0 is -360. Same thing over here. Let's plug -1 into that. 360 times -1 is -360. And -360 plus 180 is -180. Now at this point, I'm going to stop and I'm going to look at my answers and my possibilities here, because I wanted to find all the answers that are between -360 and +360. Now notice that for the -360 there's an equal sign, so we do want to include the -360, but there's no equal sign for this one, so we don't want to include a +360. So I'm going to cross this one off. We don't want +360. I do like the -360. -180 is between those two numbers, so that's a good solution, and so is 0, and so is 180. 540 is too big. It goes outside the range, so we're going to get rid of that. Now, obviously, if I were to go on into n equals 2, if I plugged in 2 here, that's going to be too big. I'll write the answer, but we already know that's too big. It goes beyond 360. Same thing over here. If I plugged in -2 to this one, what would that give me? That would give me 0, 0. Gosh, I don't know if I can even do it in my head. 180 times 720. 900. There we go. That's too big also. So we don't want that. And obviously, if I were to plug in -2, we're already at the limit here. We can't go past -360, so there's no point in plugging in -2 there. We could try plugging in -2 to this one, but I'm pretty sure that's not going to work. Yeah, that's still going to, that would give me -540. So we found all of our answers. And so here are the solutions. These guys here. Okay, so the answers to this equation are, if you want to put them in order, -360, -180, 0, and +180. There's all the answers. So there's an infinite number of solutions to this. So I found my general solutions first, and then I just kept plugging in different values of n until I found all the possibilities that are between the values that they wanted me to do. Okay, now a little hint for you is, notice I started with n equals 0 in the middle of my table. I would encourage you to do the same, just so you kind of get a feel for, maybe sometimes you need to go backwards, sometimes you need to go forward. So, but there's that. So this one actually ends up having 4 solutions on this interval. Let's go ahead and do a second problem here. This one is for radians. So let's go ahead and do some radians here. So if I wanted to solve this, the first thing I would do is I would divide both sides by 2. And that gives me -1. Looking at my tangent unit circle, tangent equals -1 in these two locations here. But we really only care about one of them, because when you're doing tangent, the general solution only requires one answer. And so the one that's right there would be 135 degrees. But remember, we're doing radians, actually. I forgot about that. So in radians, that would be 3 pi over 4. So 3 pi over 4. All right. And the period for tangent is 1/80 or pi n. Okay. And so there's my general solution. Now for this one, we only need one general solution. We don't have to find this other one. So in some senses, it'll be a little bit less work. So let's go ahead and set up a little table here. So we have 3 pi over 4 plus pi. And now let's go ahead and do our n values. So let's start with n equals 0. Got my n there. So if I plug 0 in here, I have pi times 0, which is 0. And 0 plus 3 pi over 4 is just 3 pi over 4. So there's that. Let's go ahead and plug in n equals -1 and see what happens. If I plug in -1, I'm going to show my work over here on the side this time because it's a little bit harder to do mental math with these ones. I get 3 pi over 4 minus pi. Getting a common denominator, I end up with -1 pi over 4, and that's less than 0, so we won't be using that one. I'll write it here, but I'm going to cross it off because that's less than 0, and we want to stay between 0 and 4 pi. So we know we can't go backwards anymore. Let's try going forwards. So let's plug in a +1 this time. And after a while, you guys might get a feel and realize, well, I'm not even going to bother plugging in because I know it's not going to work. But for now, I'm just kind of demonstrating the process of starting with 0 and then plugging in 1 and working your way up. So if I plug in a +1, we get 3 pi over 4 plus pi. And then getting a common denominator, we get 7 pi over 4. Okay, 7 pi over 4. Now, some of you guys might be wondering, gosh, Mr. Bailey, how can I tell if this is bigger or less than 4 pi? Well, one way, if you want to use your calculator, is just turn this into a decimal. Do 7 times pi and divide it by 4. And then do this one, 4 times pi. And you can see 4 times pi is going to be like 13 or something like that if you turn it into a decimal. It turns out that this one's a little bit less. Now, another way you can do it is just look at these numbers. 7 over 4. How many times does 4 go into 7? It only goes in there once, right? With 3 left over? Well, so in other words, 7 over 4 is barely bigger than 1, so that's less than 4. So that's another way you can do it. Doesn't really matter, but so far we're good because 7 pi over 4 is in the range. Let's go ahead and plug in 2. So if I plug in 2, I get 2 pi here. And if I multiply the top and bottom by 4, I get 8 pi. And 8 pi plus 2 pi is 10 pi over 4, which reduces to 5 pi over 2. So let's put that there. Is that in the range? Well, once again, you can change it into a decimal to see if it's less than 4 pi. Or you could just think, how many times does 2 go into 5? Well, 2 goes into 5 twice, which still is less than 4. So we can actually keep going still. All right, and so let's do another one. I'm running out of space here, so I guess I'll continue my table somewhere else. All right, so plugging in 3, what would we get? We would get, I think it would be 15 pi over 4. And 4 goes into 15 3 times, so we're still in range. I think if I do it one more time, it's going to go outside of the range. 16 plus 3 is 19 pi over 4. So 19 over 4. 4 goes into 19 more than 4 times. It goes in there 4 times with a little bit left over. So this one's too big. And so we have all of our answers. My first answer is 3 pi over 4, 7 pi over 4, 5 pi over 2, and 15 pi over 4. So all of those are solutions to this equation here. All right, so we did one with degrees, we did one with radians, and we'll go ahead and let you guys try some of these on your own now. So for this first one here, number 9, that's degrees, and I want you to find all the solutions between 0 and 720. And for this one over here, that's going to be in radians between negative pi and positive pi. And so pause the video here and give that a try. When you unpause it, we will show you the solution. All right, the ones that are in the highlighted boxes are the answers for each one of them. So for number 9, the answers are 0, 180, 360, and 540. For number 10, the answers are negative 5 pi over 6 and positive pi over 6. So for number 9, the general solutions are 0 plus 360n and 180 plus 360n. And then by plugging in 0, you get these two solutions. And then by plugging in 1, you get these two solutions. And after that, nothing works. If you tried plugging in -1, you would also end up outside of your range. So those are the only 4 solutions on that interval. Now we come to this guy over here. The general solution is pi over 6 plus pi n. We wanted to do radians, remember. If you plug in -1, you get negative 5 pi over 6, which is greater than negative pi, so it's in the range. And then if you plug in 0, you get pi over 6. But after that, if you plug in 1, you get too big. And so there are the 2 answers for that one. Okay, and so that's how you find general solutions in both degrees and in radians. And that'll do it for our lesson today. So we'll practice that some more in class, and we'll see you guys then. Have a good night.